Right. And with rational exponents, we've actually done a little bit of this already. We just didn't actually talk about it, clarify it. So what we're going to do in this case is, remember, rational means fractional. So whenever you see rational, just realize we're talking about fractions in this case. We did radicals, which is all, our radical symbol we're doing. Now we're doing rational, where we're going to have everything in fraction form. And we've already done this. So this shouldn't be like this is not going to be like what are you talking about? Because we've already done this. If we had some index over here and we had x to some power, what did we do with these numbers to figure out what this x was going to be? We took these, what did we do with these two things here? We were trying to figure out how many was inside and how many was outside. We were simplifying it with a variable. We did that, right? We made it like a fraction and divided it. So that's what they're talking about for this case, is that if we've got something that's in radical form, that if we need to change it and put it in rational or exponential form, that's what it would look like. Okay, and again, we've already been doing that, so that's kind of what we're looking at. Now, again, with the rational is that we're doing these. Sometimes it's going to be fractions. Sometimes it will simplify down to be a whole number. But that's kind of what we're looking at doing in this case, is just taking something in radical form and then rewriting it in exponential form. And again, we've already done that, so it shouldn't be like anything too awfully complicated, because it's just actually putting a name to it now. All right, now what they're going to have you do in this case is they're going to kind of walk us up into some things we're going to do. So if you have now I know we can do this, and we know what the answer is, but in some of these cases, they're actually going to ask you just to rewrite it. So if we have the square root of 36, they're not going to ask you to simplify it. They're actually going to ask you just to rewrite it. Again, technically, this would be index is 2, so this would be 36, and there's technically 136 would be here. So if we rewrite it in exponential form, it's going to be 36 to the 1/2 power. Okay. If we had 4th root of 16, again, they ask you just to rewrite it in exponential form. The index here is your denominator. If there is no power on the inside, then we're understood that that's going to be just a 1 that's there. So that would be 16 to the 1/4 power. All right. And again, this is another one of those situations where it's actually, to me, a little bit easier if you have variables, because if we've got the 3rd root of x squared and they ask you to rewrite it in exponential form, that's going to be x to the 2/3 power. Okay, so there's one where they give it to you in radical form and ask you to rewrite it in exponential form. And again, they're saying it's kind of rational because most of the cases it's going to wind up being a fraction, which is what makes it rational. But that's exponential form that we're looking at. Okay, and then let's go with the other route for this thing. Let's have it so that when we're going through some of these, let's write it in radical form. And again, we're still not solving. In a minute, we'll actually come back and start solving some of these. But right now, we're just rewriting it just to make sure everybody's fairly comfortable with this thing. Let's go x to the 3/7 power. So now they're saying, all right, now it's in exponential form, which really winds up being rational because we've got the fraction with it. So if we rewrite it in radical form, main thing is the 7 on the bottom, that's your index. And that 3 becomes your power there. Now we're going to do a little OR on this one, because you actually could write these two different ways. You actually could write it as the 7th root of x, and then you could put your third power out there. Now, most of the time, this is probably our better choice, but when they ask you to start simplifying it a little bit, we actually start working some of these, we're actually going to do it this way because it'll be easier to use a calculator to kind of get the answer in that part. So if it's w to the 5/8 power, eighth root of w to the 5th power. All right. Or again, it could be that's the 8th root of w and then 5th power. So this one you're doing the 5th power first, and you're taking the 8th root of it. This one you're taking the 8th root of it, and then taking that to the 5th power. So it's just a matter, and there's not really a right or wrong way. It's just a matter of which one can you work out to be a little bit easier when it comes down to it. All right, if you happen to get a negative power, if it was negative 5/8, if we think about this, let me kind of flashback for a minute here before we do the negative. Let me just put this on the side over here. Does anybody remember, and I think we talked about this, what if we had x to the negative 2 power? Not in this case, no. Do we?
1 over x squared.
Yeah, that if it's x to the negative 2 power, the only difference between x squared and x to the negative 2 is that if it's a negative exponent, you're going to rewrite it as 1 over that number. So if you have a negative exponent, it's almost like it's in the wrong place. Do what? Well, actually, so in that case, what you want to think about is that if you have a negative exponent, you're going to move it from numerator to denominator. Or if it's in the denominator, you move from the denominator to the numerator. So basically, a negative just tells you it needs to be a fraction and it's in the wrong place. So if it's w to the negative 5/8, it's going to be 1 over w to the 5/8. And then we change it to rewrite it. So it would be 1 over the 8th root of w to the 5th. All right, now here's where it gets a little creative. If it's x to the 0.2 power, most people go, all right, it's a decimal. What do we do with the decimal? All right, can we change the decimal to make it in a fraction form? Can, right? So if it's 0.2, that's in the 10th place, right? So that's 2 over 10, which would really be 1/5. Okay, and then that part would turn around and change it, so that would be the 5th root of x to the 1st, but we don't need the 1 because it's just x to the 1st. So if any, and that'll work for any decimal. You know, if it had been 27, it would have been 27 over 100, and that would have been the 100th root of x to the 27th power. So anytime you get a decimal that they happen to throw in there, just realize that you can take that and rewrite it in fraction form, and then you can make it go from there. And then I don't know that you'll get this, but let's just give you just in case. What if you have y to the 3 1/2 power? All right, it's a mixed number. How do we make it a fraction? Yeah, do the 2 times 3 plus the 1, right? So make it y to the 7/2 power. And then since that's a fraction, even though it's improper, it's still okay. That means we're going to do the square root of y to the 7th. And because it's square root, you don't have to put the 2 there. So it's understood that that thing would be there. Okay, now here's one where they're going to actually kind of give you some problems for some of these, and they may ask you to not just rewrite it, but rewrite it and simplify it. Okay, so it's not just a rewrite, but it's also rewrite and simplify. So we've got 64 to the 1/2 power. All right, if we rewrite it, that is the square root of 64 to the first power. Again, we can put the 2 there, but technically we don't have to because square root, we don't have to put that 2. Just understood that's there. Square root of 64 is 8. We do not have to worry about any absolute values in this case because they'll tell you just assume, that the answers are positive. You have to run across that. All right, so we've got 11 to the 1/2 power and 11 to the 1/2 power. That's kind of like the one up here, right? Square root of 11 times square root of 11. And now we're back to what we've been working on the last few days. If we've got these two things multiplied together, just multiply it together and make it 121. And the square root of 121 is, there you go, just 11. All right, so let's go 3 to the 1/2 power times 12 to the 1/2 power. All right, so square root of 3 times square root of 12. Square root of 36. Just 6. It's possible, and we're actually going to do something different here in a second. We'll show you how you can actually do this differently than just the rewrite and simplify for this part. But let me give you one more of these. Let's do 4 to the 1/3 times 4 to the 1/3. Yeah, and actually this problem will answer that question for you because this one won't work out perfectly. So this is the third root of 4 times the third root of 4. Index are the same on both of these, so we can do 4 times 4 to make it 16. And if it's third root of 16, what we said yesterday is that if you've got it rewritten, so we're here, once you get to this number, you've got to start breaking it down, see how you can rewrite it. And if you think about third root of 16, 16 is 4 times 4, which is 2 times 2, which is 2 times 2. So that would be third root of 2 times 2 times 2 times 2. Yeah, so we need pairs of 3, so that 2 will get out. That 2 stays on the inside by itself. So that'd be 2 on the third root of 2. Okay, so there may be some where, in a lot of these cases, if they ask you to rewrite it, it's probably going to be a perfect radical. But there may be some of these after you rewrite it and then simplify it, you're still a possibility of not getting something to work out just perfectly when it comes down to it. Okay, so here's the actual, now here's where we kind of get to the exponent properties when we're going through these. There's certain, now some of these y'all already know, so it's not like every one of them's going to be brand new, but a couple of them we're going to kind of sneak in on you here just to make sure that we got it. But these are the exponent properties we're looking for. And after we go through the properties, we'll give you examples of how these would look when you actually have to do something with them. Okay, so the first one is if you've got 2, it's the product property. If you're doing a to the n power and a to the n power. And for these, we're assuming that the bases, in most cases, are the same. So if the bases are the same and you're multiplying these, you're going to take the 2 exponents. Just think about if it was x squared times x to the third kind of a thing, that you're just going to add those exponents together. And that, again, that was not really anything new because you've been doing that one for a while, but that's just kind of backing up and saying that. That's m plus n. So that was if we were doing, x squared times x to the third, we know that would be x to the fifth. All right, so we knew that if we did multiplication, you add the exponents. If you do division, then you have to subtract the exponents. Because I think these are the two that you've done for a while, so it's not really anything new. It's just go back and remind you. So if you had x to the 10th over x to the 7th, you would subtract 10 from 7 and get x to the third. Okay, and this is one, we'll do this one, but you have to kind of expand on it just a little bit. If it was ab to the m power, that's going to be a to the m power and then b to the m power. Okay, I always like to expand this one a little bit because sometimes it's not real obvious. So let's expand this one just a little bit. Let's say you had a to the x power and then b to the y power. And we're going to take that on the outside to another power. That basically it's like distributive property, that we're going to wind up with a to the xp power and then b is to the yp power. So whatever you have on the outside here, that you can almost think about those as being like ones here, that it's m times this and it's m times this. That you got to take whatever this power is on the outside and actually distribute it. You got to multiply it by every power that's on the inside. Oh, I actually skipped one. I skipped the one ahead of this. Oops, my bad. I skipped the one. For some reason, I skipped the one that was before this. That if you had a to the m power to the n power, it would have made more sense if I'd done that one first. Then you multiply those two things together. It should be that to the m times n power. I don't know why. My eyes just skipped over that one for some reason. So if you had x squared to the fourth power, you would do 2 times 4 and make that x to the 8th power. Okay, and then one last one. If you had a to the negative m power, and we just got to finish talking about this one, that you would basically write that as 1 over a to the m power. Okay, so the negative is basically just a marker saying, all right, if you have a negative exponent, it's almost like it's saying it's in the wrong place, really is what it's kind of up to. So if you had a problem where it was like 1 over x to the negative 2 power, that this x to the negative 2 is in the denominator, then that means you need to move it from the denominator up to the numerator. Okay, so that's kind of the way I think about it. Some people may not exactly say it that way, but that's my thought when I see that. When I see a negative exponent, it's just, okay, it's in the wrong place. I got to move it from numerator to denominator, or if it's in the denominator, I got to move it from the denominator to the numerator. Okay, so there's our 5 properties. And again, these two are basically the same. They're just extensions of each other. And these two kind of sort of go together, but not really. They're kind of different with it. All right, so then they're going to ask you, all right, use your properties to simplify. And sometimes they'll just say simplify. Sometimes they'll say use your exponent properties to simplify. So it just depends on how they word this thing. we got 8 to the 1/3 power times 8 to the 2/3 power. Okay. Now, in this case, they don't ask you to rewrite it just like we were doing earlier, because some of these back here, the first problems where they were asking you just to rewrite it in radical form and then solve it. In this case, they're not asking you to rewrite it. They're saying, all right, just tell us what the answer is, because there's a lot easier way to get the answer than rewriting it as the third root of 8 and the third root of 8 squared, because they want you to kind of realize that you've got the same bases here. So you can take that 8 and do 1/3 plus 2/3. Because this is a whole lot quicker to do it this way, because what's 1/3 plus 2/3? Yeah, that's 3/3, which is 8 to the first power, which is just 8. And that's a whole lot faster than rewriting it as the third root of 8 and then the third root of 8 squared, and then putting all those numbers together and then breaking them all down to get all these numbers. So if you've got the same bases, you don't have to do that. You really could have done that back here with these problems, but they ask you to rewrite it first. Like this one would have been a lot easier to do 11, 1/2 plus 1/2, make it 11 to the first power, which would have just been 11. Okay, now if the bases are different, all bets are off. You kind of have to do it this way, but if the bases are the same, you could do it like we're doing here with this one. Okay, so if the bases are the same, use your properties. If the bases are different, then you're going to have to rewrite it and combine some terms and do some simplifying and that kind of stuff. All right, so let's say we got 5 to the 1/2 power to the 4th power. So in that case, we're going to do half of 4. If you do half of 4, that is just 2. And then 5 squared is 25. There you go. Okay. Now, if they give it to you, here's where we're going to change it a little bit. So this is one of those cases where if they give it to you this way, you don't have to rewrite it, but it really probably is better if you do rewrite it. Because if you have the square root of 3 times the 4th root of 3. And if you flash back to what we were doing yesterday, we're talking about if you're multiplying radicals, the index has to be the same in both of them, right? And here they're different, so most times you'd go, oh, no, you can't do anything with it. But today what we can do is we can actually kind of rewrite it, right? So before we do anything with this one, let's rewrite this as 3 to the 1/2 power times 3 to the 1/4 power. And now that the bases are the same, you can just add your exponents together. You can do 1/2 plus 1/4. Make sure you get your common denominators first. So that would really be 2/4 plus 1/4. If you rewrite the common denominators, that would be 3 to the 3/4 power. Okay, did it simplify? Not really, because if we do that, there's not really a way that was going to simplify. So for that part of it, we'll just leave it as 3 to the 3/4 power. Okay, now, if they ask for it in exponential form, that would be your answer. If they ask for it in radical form, then we've got to rewrite this thing in radical form. So it would be the 4th root of 3 to the 3rd. Okay. And it'd be great if these canceled each other out, but they don't. So in that case, that would be the 4th root of 3 to the 3rd power. That would be 27. So that would be it in radical form. And it's kind of, it's 50-50 on what they're going to ask. Sometimes they'll let you leave it in exponential form. Sometimes they may tell you if you started with radical form, they may ask you to rewrite it in radical form, just because this looks a lot easier than that if you talk about it in radical form. All right, so let's go 16 to the negative 2.5 power. All right, my first thought when I'm doing this one, anytime I've got a negative exponent, before I do anything at all, I'm going to go ahead and rewrite it as 1 over 16 to the 2.5 power. Go ahead and fix the, because I always tell people, fix the negatives first. Get that part out of the way so then you're not worried about anything else. So we had 16 to the negative 2.5. That's basically in the numerator. The negative exponent means it's in the wrong place, so now we're going to put it in the denominator. So now from here on out, you can just kind of ignore the 1 that's on top, and we're just going to worry about this thing. So if it's 2.5, that is what, 2.5? If it's 2.5, if we make it from a mixed number back to an improper fraction, that would be 5 over 2. So 2.5 is 2.5. If we take 2.5 and change it back to a improper fraction, that would be 5 over 2. And why that helps is, what happens if you do the square root of 16 to the 5th power? Now, let me ask you this much. Now, here's 2 questions. Does anybody know what 16 to the 5th power is? Off the top of your head. Does anybody know what the square root of 16 is? That's 4, right? Yeah. So if you have these, and this is kind of why we were rewriting those earlier, if you have some numbers and you look at this and you go, all right, I've got 2 options. I can either do the square root of 16 first, or I can do 16 to the 5th power first. I'm going square root of 16, right? Because I can figure out square root of 16 is just 4. So that's going to be 1 over 4. And then I can bring in my 5th power that's there. So I'm going to do this part first because I can do that part and make sense of it. I cannot do 16 to the 5th in my head. It's just not there. But I can do square root of 16 in my head. Now, if you had to, this was the apocalypse and all the calculators were gone, you could do 4 to the 5th power, right? A lot easier than you can do 16 to the 5th power. So if we do 4 to the 5th power, that's what? 16, 64, 256, 1024. So if you do 4 to the 5th power, that'd be 1 over 1024. Okay, so we're trying to prepare you for the zombie apocalypse, that if the zombies take over and, they eat all the calculators and you got to do stuff by hand, then, they're mistaking your calculators for brains, right? Because it does the work for you. They want brains, so they eat your calculator.
All right.
Yeah, that's just a bad joke. So. Okay. All right, let's get a little more creative here. So we got negative 32 to the 4/5 power. Okay, now for this one, don't think we're going to put this as 1 over because the difference is, where's the negative here? It's in the exponent, right? If it's just a number that's negative, you don't have to worry about it. It's only when it's in the exponent that you've got to make it a fraction. If it's just a number that's negative, you don't have to flip this thing around. So it's negative 32 to the 4/5 power. So let's rewrite it so we can actually do this. So we've got the 5th root of negative 32. And notice it's in parentheses, so let's leave it in parentheses. To the 4th power. Okay, and here's our options we've got. We can either do the 5th root of 32, or we can do negative 32 to the 4th power. We can check this real quick, right? If we check 5th root of negative 32, because if it's, powers of 2. So if you check the 5th root of negative 32, let's see what we got here. We got the 5th root of negative 32. That's just negative 2. And it doesn't matter which one you check it with, any calculator, if you do the 5th root of any number checking on this one, negative 32, that's going to come out to be negative 2. So that's negative 2 to the 4th power. And then if you do negative 2 to the 4th power, if you multiply negative 4 times, it's going to make it positive. And 2 to the 4th would be 16. Now you could do negative 30. Now if you do it this way though, if you do negative 32 to the fourth power, you could get that number, which we all know that off the top of our head, right? Yeah, that's easy. And then you could then take the fifth root of that number and go back and get the same answer. But it's a lot easier to do the fifth root of 32. So that's what they're kind of saying in this case, is that most of the problems on these, it's going to be easier to do the radical part of it first, where you go ahead and take the root part first, and then come back and use your exponent to then do the answer. There might be an occasional weird one where you wouldn't do it that way, but almost every single one of these, that's kind of the route that you want to go through. All right, getting close. Yeah, it was 16. All right, let's go 16 to the 3/4 power. All right, and if anybody knows that right off the top of your head just by looking at it, that's fine. But again, if we rewrite it, it's the fourth root of 16 to the third power. And we just got doing the fifth root of 32, which was 2. So anybody want to take a guess what the fourth root of 16 is? It's just 2, right? So that's 2 to the third power, which is 8. Okay. So again, check the radical part of it first. And then once you've got the radical part, then you can go back and do your exponents on those. All right, let's go with 9 to the negative 3.5. All right, again, in my mind, first thing I'm thinking is that negative is in the exponent. So I'm going to rewrite it as 9 to 3.5 and do 1 over that 9 to the 3.5. That way the negative is gone. We don't have to worry about the negative anymore. All right, again, 3.5 is 3.5. So if we make that back into a improper fraction, that's 7 over 2. Which means that's the square root of 9 to the 7th power. All right, again, I ask the same question. Does anybody know 9 to the 7th power right off the top of your head? No. Does anybody have a square root of 9 off the top of your head?
3.
That's 3, right? So we can make that 1 over 3 to the 7th power, and then we can just use our calculator to do the 3 to the 7th power. And that's 2187. There we go. Okay. And again, you're almost always going to do the radical part of it first to get a smaller number. And then once you got a smaller number, then you can do the exponents and make it get bigger. All right, 2 more, and then we're done. So let's go 8x to the 15th power. Let's make that to the negative 1/3 power.
Is that like the whole thing? X to the 15th or just that?
It is 8 and then x to the 15th power. Okay. All right. So yeah, in that case, you can kind of, and it was not there, so you can almost think about the numbers as having an exponent also. So it's almost like it's 8 to the first power and then x to the 15th power. So if you want to think about it that way, that's kind of the way you want to think about those problems. All right. Before I do any of that though, you've got the negative exponent. So that means, and it's this whole thing to the negative 1/3 power. So I'm going to go ahead and just rewrite it as that, but make it, take the negative away. So it's 8x to the 15th and to the 1/3 power. That way, again, the negative exponent's gone. We don't have to worry about it. We can worry about this part of it. All right, and here's where you have like two options. If we stick with our properties, this is 1 over, again, that's 8 to the first power. This becomes 8 to the 1/3 power. And then if we do 15 times 1/3, if we take 1/3 of 15, that's basically 15 divided by 3. That becomes x to the 5th. So the variable part's good. We just got to work on this 8 to the 1/3 power. And if you have 8 to the 1/3 power, that's the third root of 8. Technically to the first power. But again, not going to do anything. Third root of 8 is just 2, right? So final answer for this one would be 1 over 8 to the 1/3 is 2. So that's 2x to the 5th power. Okay. Last one of the day. I promise. And not like yesterday, we had one more, and then another one more, and then like another one more.
Yeah, let's not do that.
Yeah. This is the last one.
Are you sure?
Promises.
Well, you like
I'll do like Gru. I swear with the pinky. The pinky swear, Gru. You know, Despicable Me. Okay, I must swear with the pinky.
Like on the board. My board.
Yeah, like, yeah, we got Gru up there. So,
Of course the last
all right, let's go 9x 4th root of y to 3/2 power. All right, first thing is, it looks weird to have a radical and an exponent here kind of all mixed together. So before we do anything, let's get rid of that radical and just rewrite it as y to the 1/4 power. Because it's kind of weird to have a fraction and a radical kind of mixed together. So let's just change this thing to a exponential. So now we've got all exponents through here. Okay, and similar to the last one, this is you got to think about this as 9 to the first power, x to the first power, y to the 1/4 power, and you've got to distribute this 3/2 to all those things. So that's going to be 9 to the 3/2 power. That's going to be x to the 3/2 power. And when you multiply y, that's going to be 3/8 power. Okay. And this should be one that in the question that they should have told you to write this answer in radical form. Because they should give you a hint ahead of time how they want the answer, whether they want it in exponent form or radical form. So just depends on how they go through that one. So if we take it one little piece at a time here, this would be the square root of 9 to the 3rd. But square root of 9 is 3, and then 3 to the 3rd is 27. Okay, if we go with the x's for this thing, and this is kind of where I like the division part of it, or you can think about it for this part of it. I'm going to do the x to the 2/3 over here. All right, but think about this one. We're going to take 2 and divide it into 3, right? 2 going to 3 one time with 1 left over. And then for the y's, we're going to divide 8 into 3. Well, 8 doesn't go into 3, so that means we're just going to have 3 that's left over there. Okay, so if we're going radical form, top numbers tell us how much gets out. Bottom number tells us how many stay on the inside. Now, the one thing that's a little different on this one, is that if you think about this one was this one's a square root, this one's an eighth root. We can't combine those two together, so this one's actually going to stay like two separate things. So for the x, we're going to get one x that's on the outside. We're going to have one x that's on the inside. And because this one's going to be eighth root, it's going to have to stay over here by itself. Okay. Now, if they were both square roots, we could have combined the two parts together. But because this one's an eighth root and this one's a square root, they actually will have to kind of stay separate. So that's what makes that one a little funky. Because a lot of times on these, when we get here, we put it all together. But that's if you're dividing by the same number. If you're dividing by different numbers, then they're going to have to stay two separate parts when it comes down to it.